Okay, Bismillah ar-Rahman ar-Rahim. I just wanted to record the final segment of this lecture to show you what was wrong. And the error is really silly, and it can happen because you forget that you're dealing with fixed point numbers. Here, in the multiplication, if you're multiplying integers, this is fine, okay? But we are multiplying actually fixed point numbers. So we cannot do this actually. We have to do it using fixed point multiplication. So for this, I need to actually do the multiplication in an intermediate state between S4 and S5. So I'm going, instead of going to S5, instead of going to S5, I'm going to state S45, which is defined here in the well, S45 is already there, so I'm going to make use of that. Okay, so in S45, the main thing is that I'm going to calculate two intermediate result for both A square and B square. So I have one for A square. Right? Basically, if you want to calculate this, you just multiply A times A, but you need to make sure that the result fits. Okay, IR1 fits the multiplication result. Okay, and then IR2 is basically B times B. Okay, and the state is S5. That's all. Okay, and then you go to S5, and in S5, instead of taking A times A, I'll take IR1, but shift it to the right arithmetically. Okay, this is arithmetic shift right. Okay, so that we replicate the sign bit instead of replicating the what we call instead of shifting in a zero. Shifted in by or shifted to the right by scale. This corrects the multiplication basically. Okay, as a fixed point number. And then also IR2 intermediate result 2 shifted to the right by scale. Okay. One more thing we forgot is to actually set ready to 1. Okay, set ready to 1. Since we set D out, we need to set ready to 1. Okay, otherwise ready will not be set to 1 ever. Okay, that's why we got an infinite loop waiting for ready in the test bench. All right, so we need now to define or declare IR1 and IR2 to be able to hold the value in A square and B square. So let me just create definition here for so this is 2 times width minus 1 to 0. That's IR1 and IR2, right? Okay. Now I can go to the test bench and change it so that I get this back here, okay? Because I know that inshallah it will work now, and wait for 50 more block cycles and then finish the simulation. Okay, so before we actually jump into the simulation, I would like to calculate the result so that we know what should be the result in order to see whether our result is correct or not. So 3 squared plus 2 squared, which is 13, okay? And you take the square root of that, you get 3.605, okay? If you get something like that, then you're close enough, okay? 3.605. Okay, let me go to the compile. Let's compile my code and run it. Okay. Actually, there's still a problem with Let's set this back to what it was and see what is wrong again. Right, so now I'm going to reload, and you can see that the out is completely disconnected here. Probably the reason is something silly. Let me see what's the reason here. The out is square root the out. Okay. IR1 scale, IR2 scale. Let me use just shift logical for now. It's just to rule out the problem of no, it's not because of that. Let me pause the video and then get back to you once I find the issue. Okay, the problem was because so I'm going to get this back to what it was. There is nothing wrong here, except that it's a precedence. So I need to surround this by parentheses here, okay? Because otherwise, the addition has higher priority than the shift operator. So it will add scale plus IR2 and then shift by IR shift. I mean, this will be a shift amount for IR1. So you'll get a 0 in IR. Anyway, so this fixes the problem. So again, you can see that I just ran this, and you can see that actually the square root is correct. The hypotenuse is correctly giving 3.605. And just to be in the correct, it shows you that this is actually working. Okay, let's just compile this again. Right, and it exits because what? Because actually ready goes to 1. Okay, in this case, and you can see that reload, it doesn't continue all the way to 500 nanoseconds because it doesn't need to. So the result here is shown at the end like this. You can also check other numbers. I'll upload the scripts to the Teams channel. Play with the before doing the homework, the Verilog code before doing the homework, and make yourself comfortable with it. One more thing probably to check if this works or not is to probably try a negative number. It shouldn't change the result, by the way, because because it is squared, yeah, it is squared, so I should get the same exact result. So, but and this is actually it should be sign this one. Sorry, choice sign this one. So it's -3 and 2. The result is still 3.605 because you're squaring the -3 and you're getting basically a positive number potentially. Happy coding. Let me stop recording and see you soon.